Good day, metric class of 2023. I have your mathematics paper 2 here that I want us to discuss, more especially those troublesome questions. I've been getting a bunch of emails from different schools and different students, including teachers as well, to say what is my approach on 3.7 and 3.8 as well as 4.6. So let me start with question 3 and we see how far we can go with this. Question 3. I'm just going to underline that. And then 3.1. They are giving you guys the love letter here, which is also shown in terms of the triangle in the Cartesian plane right there. You also have the angle of inclination, which is theta there. And one thing that you have to note here is that we are dealing with a right-angled triangle here because of angle L there. It is 90 degrees. Therefore, SL is perpendicular to LN. But let's answer the questions properly. Calculate the length of SL. So SL will be equals to the square root of x2 minus x1, and then you square this plus y2 minus y1, then you need to square this as well. Okay, and then now it's a matter of substituting. I don't think it's a problem. It's a grade 10 work now. So you have x2, I'm going to start from the point S, minus 4, so it's plus 4, then you square this, and then you have 5 for the y, take away 1 from the point L, and that is going to boil down to use calculator properly here. Because it's 2 marks, I'm not going to really have a lot of steps. Let me have 80 here. And then they want this answer in terms of the third form. I don't think it's really bad. You just need to say 9 times, 16 times 5. That is going to give you guys a 4, the square root of 5. Now, 3.2, they say calculate the gradient of Sn. So the gradient of Sn is normally the change in y of, the change in y over the change in x, which is y2 minus y1 over x2 minus x1. Let's substitute everything of Sn. So I normally like to start from the positive points. So in this case, it's going to be 5 minus 3, which is plus 3, over 4 minus 2, so it's plus 2, which is going to give me 8 over 6. And as a result, I'm going to get 4 over 3 because 2 can get into, it gets 4 times the numerator and 3 times your denominator. Okay, so now we get to 3.3. Calculate the size of theta, the angle of inclination of Sn. So remember that you have the formula, which is tan theta equals the gradient of that particular line that the inclination makes with the x-axis. So I'm going to write Sn, which is equals to 4 over 3. Therefore, theta will be equals to the arctangent of 4 over 3. And as a result, we are going to get theta as what? We use calculator here wisely, and then we are going to get a 53,13 degrees. Okay, that's how you would go about it. And then 3.4, they say calculate the size of LNS. So let's try and mark that angle that they are looking for. So they are looking for this angle here. This is what they are looking for, angle N in that triangle. So I'm just going to highlight that. This is what we are looking for. Beautiful people, angle N. So like I said in the beginning that this triangle, it's a right-angled triangle. Okay, so you can use trig ratios here to say that you have the distance of SL, right? The distance of SL is going to give us a 4, the square root of 5. And you can also have the distance of LN. Okay, so you have the distance of LN there, which is, you can find that. You can really find that. It's not really a major issue. the distance of Ln. So let's do that. Let's get it quickly. So that is going to be minus 4 plus 2 squared. So that is going to be minus 2. Then you square that, is going to be 4 plus 1 minus 3. So it's 4. Now you square it, it is 16. Okay, so this gives us the square root of 2 root 5. Okay, so now that you have now you have 2. Now you have 2. You have 2, the square root of 5, and then here is 4, the square root of what? Of 10. Oh, wait. It is square root of what? I think we found this particular question. That was 4 root 5. It's SL, the first question. And that means you can also find the length of NS. That distance, you can also find it. That is 10 units using Pythagoras theorem, right? Yeah, use Pythagoras. You're going to get that particular distance there because it's a right angle triangle, hence Pythagoras. So now, how do you find that it's a right angle triangle? So I'm going to use the trig ratio here. So let me use the tangent one because of that angle is going to be opposite to that one. So that is opposite. So let's use that quickly. The tangent of LNS is going to be 4 the square root of 5 divided by the adjacent of it, which is the square root of 5d. Therefore, the tangent of LNS is equals to, that should be 2, carefully there. There should be 2. Therefore, LNS is equals to the arctangent of 2, which will give us 63,43 degrees. Okay, you could have done it in different ways. Like in this case now, you can use the sine trig ratio. You can use the cos trig ratio as well, which we are going to be focusing on that for the cos trig ratio. It will be the adjacent over the hypotenuse. Right there, you will still get the same answer. Or you can use the sine trig ratio right there. I don't have time to show you all of those methods, but they can all work for that one because it's a right angled triangle. Okay, so the angle here is 63,43 degrees. I forgot to write the degrees there. Don't forget to write it out. Okay, so that is 3.4, and that is my approach to that particular question. Now let's check the next question. What are they saying there? That is 3.5. They say that determine the equation of the line which passes through L. So we must use the point L and is parallel to SN. So we have the gradient of SN, okay, which is what was it here? That was 4/3. Its gradient. So I'm going to say that this is y equals to mx plus c. Therefore, y is equals to m, which is 4/3, is parallel to SN. They're basically saying they have the same gradient, then plus c there. So now I have to use point L. So I will say that the point L is -4 and 1. Therefore, you take that point and plug it here to get the value of c. So that is 1 is equals to 4/3 into -4 plus c. Therefore, c should boil down to 19/3. Okay. So therefore, the equation here of interest in the form of y equals to mx plus c, that is 4/3x plus 19/3. That is how you will really do that particular question. And it wasn't really bad. It was a straightforward question. Let's look at the next question. And that is 3.6 now. Okay, 3.6. Calculate the area of this triangle. So this triangle, like I said, is a right angled triangle. So what you will do is you will say that because it's a right angled triangle, okay, so I'm not going to stress myself. The area of a triangle LSN is a right angled triangle. So this should be a 1 over 2 multiplied by the base, okay, multiplied by the perpendicular height. I don't have to really stress that much there because it's a right angled triangle. So that is 1 over 2 multiplied by the base. The base of this is 2, the square root of 5, multiplied by the perpendicular height, which is SL, and that is 4 multiplied by the square root of 5. So you'll see that this half there, they are going to undo each other. So you're left with 4 multiplied by root 5 times root 5 is 5. And that is going to give you guys a 20 units squared. Remember, this is the area, so it must be units squared. Alternatively to this problem, let me just give you another method to solve this. Alternatively, you can use the area rule from grade 11 to say that the area of this triangle, it's LSN is equals to 1 over 2 multiplied by the size of the included angle. In this case, it has to be ln, and that is 2 the square root of because of space, allow me to do it here. So it's going to be 1 over 2 multiplied by ln multiplied by sn, okay, multiplied by the sine of the included angle. In this case, it's ln as what we found, I think, in 3.4. So that is going to give us 1 over 2 multiplied by ln, that is 2 the square root of 5 multiplied by that is 10 now, that should be 10, multiplied by the sine of that angle. So we got that angle to be 63,43, right? So because I don't want to make mistakes, let me write 63,43, and I put those dots to say that I didn't round it off, because if you round it off, it's going to give you some weird stuff. So if you type that nicely, it's going to give you guys a 20 units squared. So this is the alternative method to this particular problem. It wasn't really that bad, it was straightforward, and I think it's a grade 10 content. Now 3.7, I think I must start from the new page because that was the request from different schools. So 3.7, they say that calculate the coordinates of P, which is equidistant from the point L, S, and N. You know, I had 5 ways to do this problem. But let me give you the easier one that we all can relate to it. So because the point L, we don't know which quadrant it belongs at this point. We don't know. So let me say that let P, which is XY there, be any point in the Cartesian plane. Hey, let this be any point in the Cartesian plane. Okay, let that be any point in the Cartesian plane. So they are saying that which is equidistant from L, S, and N. They are giving you 3 marks for that. You know, my approach is going to be a bit longer, but that is the meaning of equidistant. It means they have the same, distance throughout. So by that I mean that the distance of PL is the same as the distance of PN. This means the equidistant points. Okay, they're the same distance. Now, to look at it, you say that the distance of PL is going to be this distance here. I mean, PL. P you don't know, so that's from that point X into L. So it's going to be plus 4 now. It's going to be plus 4. So it's X plus 4. And then a plus, but I have to square this, eh? And remember, we're at L, PL, I meant to say. So it's going to be Y, if you start from the point L. It's going to be Y minus 1 at L. So then minus 1, you square this, equaling to Pn. Still, it's going to be X, but you go to N now. That should be a plus 2, eh? Plus 2, you square this, and then you go to Y now. It's Y plus 3. Should be plus 3 now, and then you need to square this. Now, you need to expand this nicely. You need to expand this nicely. And I don't have enough time to expand it, but let's do it. It's x squared plus 8x plus 16, and then a plus y squared minus 2y plus 1 is going to equals to, let's do that. It's going to be equals to the expansion of this as well. So that is x squared, and then a plus 4x, and then a plus 4 plus y squared plus 6y plus 9. So you can do some cancellation method there, that this is going to cancel with that, you know, this is going to cancel with that y squared and that y squared there. And then you have to group this nicely. So if you do that, you're going to get the first equation, which is going to be 4x minus 8y equaling to negative 4. And then you make x the subject of the formula, or y. In this case, it has to be x. So it's going to be 2y minus 1. Okay, this is minus 4, by the way. So you get that as the first equation. You get that as the first equation. And then now the other one should be, remember, it is equidistant. So you said Pn is the same as the distance of Pn. Okay. So now they also said the point S as well. So I'm going to say that the other equation, it's PL must be the same as PS. It is equidistance of 4 points. So now you do the same stuff. So PL, I think we had it, that was x plus 4, and then you square this plus y minus 1, and you need to square this as well. PS now, PS, so it's going to be x minus 4 at S. Okay, so it's x minus 4, and then you square this plus y minus 5 at S, and then you square this. Again, here you remove the brackets properly, you're going to get 16x plus 8y is equals to 24. You can still divide here both sides by 8, because you can see that 8 is can get to each term. So this will be y plus 2x is equals to 3. Okay, and this gives us the second equation. So now I'm going to solve this simultaneously, and it's very long, you can see that, but that's how you should really apply that concept of the equidistance. So I would say substitute 2 into, I mean, this should be 1 into 2. It's simultaneous, guys. Substitute 1 into 2. So x is 2y minus 1. So this should be y plus 2x. X is 2y minus 1 is equals to 3. So this gives us y plus 4y. This should be 4y minus 2 is equals to 3. Therefore, 5y is equals to 5, and y is equals to 1. Okay, and you say that x now from equation 3, it is 2y minus 1, which is 2 times 1 minus 1. Therefore, x is 1. So x is 1 then. Okay, so that means that the point P that they're looking for here is 1 and 1. Okay, that's how you really solve that particular equation of equidistant. Now, you need to answer the next question. Like I said, I had 5 ways to do it, but this is the one that really works in terms of the equidistant arguments. Okay, that means the distance from each point, they should be the same. Okay, that is my logic around that space. And then 3.8 is a grade 10 concept actually. Calculate the size of LPS. LPS. Okay. So now allow me to do it in this way. LPS. If you guys check something here, you'll see that okay, let me just try and get some more color here. If you guys check point P is 1 and 1. So now if you draw a line to try and locate that point P, you'll see that from L, this point P here, it is parallel to the x-axis. Okay, that is parallel to the x-axis at that point there. So that is where P is. It is 1 and 1. Now think about it in this way. LPS, which angle are they looking for? Now I'm gonna draw another line here to join that one, to say that what they are looking for here is nothing from the sky. It's really nothing from the sky. They are looking for this angle. Beautiful people here. They are looking for that angle. Okay. So that is what they are looking for. This angle P here. Okay. So we are looking for that angle. So what I want you guys to see here is that there are lots of ways to really attack this particular problem. You know, most especially that angle. It's not really bad. It's not really bad. So what we know is that this angle of S, but before I invite that particular view, I had 6 ways of doing it, but let me show you 3 of them for this problem to attack it. Let me bring this one back there to where it was. So now my first approach to this particular problem will be that we use, because it's 2 marks, we use those like easy formulas from the grade 11 classes to say that the tangent that is formed by that angle of LPS is the same as the gradient of LP minus the gradient of SP. You divide this by 1 plus the multiplication of their gradient, which is the gradient of LP multiplied by the gradient of SP, like that. Okay. But the gradient of LP is horizontal. Remember, I said to you, this is parallel to the x-axis because 1 is constant throughout them. So this is going to be 0 minus the gradient of SP. If you try and work it out nicely, the gradient of SP is the same as the gradient of SN, because SP and they lie on the same line. So they are collinear in that point, in that version. So that is 4/3. You divide this by, this should be 1 multiplied by 0 times 4/3. Okay, 4/3. So you will see that this is going to be negative 4/3. So therefore, LPS is going to be equals to the arctangent of negative 4/3. But because this, we don't have a negative angle for the tangent in terms of the inclination, so you need to have plus 180 degrees right there, okay, to get that particular angle. So this will give you guys a 126,87 degrees. That is my first approach to this particular problem. You get 126,87 degrees. The other way to do it would be to say that because I'm going to look at that angle in its entirety, like that triangle of LPS. So if you look at it, that triangle, you see that you have LSL from the first equation. So let me just write or. So SL, you have it, and that was for the square root of 5. Now you also have LP because y is constant. It means this is a horizontal distance. So you say 1 minus 4. So that is going to give you 5 units. Okay, LP. It's horizontal. You negate the y values if it is constant. So you focus on the x. So it's the x right minus the x left. Okay, this is normal in grade 11 classes, by the way. And then now SP or PS rather. So PS is also 5 units. If you try and work it out, you can try and find this one out. It's not from the A, but I will tell you why it's the same as 5 units. It's because when I was looking at it, I drew another circle passing through that such that PL and SP will be the radii. Okay, on that I'll also use that method as well. So you will see that this is now is going to boil down to a cosine rule, but it's 2 marks, by the way. So it's another way of doing it, however. So now you use cosine rule in this triangle to find angle P. So that is going to be 4, the square root of 5, and then you square that, is going to be equals to 5 squared plus 5 squared minus 2 times 5 times 5 cos of that angle, which is LP, which is LPS. So therefore, cos of LPS is equals to, just try to solve it nicely, you're going to get negative 3 over 5. Therefore, LPS is going to give you guys 126,87 degrees. Okay, this is how you guys would go about it. But my other approach, it's the same answer, by the way, when you work with this one. My other approach will be that, let me just say or. My approach to this will be that if you imagine it as a circle passing through these points, please forgive me if my circles are misbehaving, but it must touch those 4 corners. I hope now it's fine. Okay, I just hope that now it's fine. I'm trying to touch the point S, that's why, yes. So let me maybe give it a dotted lines like that. Cool. So if you guys check, you will see that this now is a circle, is a diameter. That means at P is the center of that particular circle. So this angle here is going to be twice that angle. It's going to be twice that angle. Okay, so now if you guys check, in a triangle SPN, you can find angle S, okay, which will be twice that angle there of P. So now you can use the angle center is twice angle with circumference. Actually, you can use that. So how do you do that? But one thing for sure, this angle is the same as that angle because of opposite equal angles. Okay, equal sides, the isosceles triangle situation. So if you do it in that way, you will still get the answer there as you still get the answer as 126,26. So now let's find angle S. So now let's find angle S in a big triangle. So if you find angle S, this should be 180 degrees minus 90 plus angle N. So angle N, we got it to be 63,43 back then. So this is going to give you something. Let me use calculator. That is 180 minus 90 minus 63,43. So I'm getting a 26,57. Okay, but don't forget that you must use the whole number there, because this we rounded up, so it might mess up with you. So it means angle S there, angle S, we get 1,26. So now what you can do is S and this angle here, these angles are equal. So you can now find LPS using a sum of angles of a triangle in that small triangle as well. Okay, so this will be 180 degrees minus twice this 26,57 degrees there. It will still give you, let me do that, 180 minus twice 26,57. We get 126,87 degrees. Okay, but you can also use the angle at center is twice angle at the circumference here. I had a lot of ways to do it, this problem, but otherwise, because of time, and I'm doing this morning, let me try and answer question 4 quickly. So question 4 quickly. Let's do question 4. They are giving you guys a circle geometry here, and that is pure grade 12. So this is now a content of a grade 12. They are giving you 2 circles. Okay, the other one is in the origin, the other one is moved from the origin by t units, okay, to the right of it. So now what are they saying? Given that D lies on the smaller circle, where smaller circle, you are given the equation there, which is x squared plus y squared is equals to 20, that is r squared. Okay, that is 20. So D lies on this particular point, that is P and -2. Calculate or show that the value of P is 4. So you're going to substitute this point into that particular circle, which is going to be P squared plus y. Y is -2. You square this is equals to 20. Okay, therefore P squared is equals to 16, and as a result P, you will get plus or minus 4. Remember, it's an equation, but P now should be 4. Why? Because D is in the 4th quadrant. Okay, so P is in the 4th quadrant, and it's positive in the 4th quadrant. X in the 4th quadrant is positive. All right, now 4.2 is 3 marks. E is the midpoint of DF. So D, what is D? Okay, D, just found it now. So D is 4 and -2. E is the midpoint, that is 6 and 2, and then of DF. So F, you don't know it, so you want to find that particular point. How many marks? This is 3 marks. Okay, find the coordinate of F. The coordinate of F will be to say that the x at the midpoint E is equals to the sum of the x of df D plus xf over 2, and then this should be y at E is equals to y at D plus y at F. You divide this by 2, therefore y at E is 2 equaling to 4 plus x at F, that is xd, over 2, and then y at E is Wait a bit, I'm messing up. The x at E is 6, hey? And then this side should be now 2, equaling to y at D is negative 2 plus y over 2. So therefore, this is going to be 12, and then 4 plus x, and then this is 4 minus 2 plus y. Therefore, x is going to be equals to 12. Okay, is it 12 or 8? I'm messing up with my brain here. 4 minus 8, that is, 12 minus 8 is 4, guys. And then y is equals to 6. Okay, therefore, f is 8 and 6, which is true because it is in the first quadrant. So we don't have to really worry about that. We are sure that it is correct because in the first quadrant. Okay, where are we going now? 4.3. 4.3, determine the equation of the common tangent df in the form of y equals to mx plus t plus c, I meant to say. So now I will need to find the gradient of df here, which is going to be the change in y minus, the change in y over the change in x. Okay, so df, this should be 6 minus 2 is plus 2 there, over 8 minus 4, and we get the gradient as that should be 8 over 4, which gives us the value of 2. So now it means that y will be 2x plus c, and we have to choose any point. So let me choose the point D, because I was asked to prove that it is 4 and negative 2. What if my f is incorrect? So let me use this one because I'm sure that is going to give me the right answer. Okay, that is minus 2 is equaling to 2 into 4 plus c. Therefore, c will be minus 2 minus 8. So that should be negative 10. Therefore, y will be 2x and then minus 10. Okay, that is the equation of the common tangent df in the form of that one. It is 2x minus 10. Okay, and then 4.4, calculate the value of t, showing all the working right there. So they want the coordinate, the value of t. So t, if you check, guys, is the x value of the center of the largest circle. So if you guys check, the gradient of the tangent, which is df in this case, multiplied by the gradient of the radius of the largest circle, and that is fg, that must give us negative 1. Therefore, the gradient of df, I think we have it, the tangent one is 2. So I'm going to have a 2 here multiplied by the gradient of fg, which we can find here. It's going to be 0 minus the y at f. The y at f, we get 6 over x, which is t, minus the x at f, and that is 8. That must give us negative 1. Therefore, this is negative 12 over t minus 8 is equals to negative 1. Therefore, this as a result should give us, you can divide by negative same time. So you will have t minus 8 is equals to 12. Therefore, t is equals to 20. Okay, if you do that nicely, I'm thinking of another method of doing it. You can find, wait a bit, you can find the equation. You can find the equation of the radius and find the equation of df and do some stuff there to still give you the same answer. I can see another method, but because of time, let me do 4.5. Determine the equation of the largest circle in the form of that. Okay, so how do you do that? You have got the center, which is D, and that is 20 and 0. And then you have the point that passes through the big circle. and that is 8 and 6. So this tells you and me that you are going to have this squared plus is 4 marks, okay, minus b squared is equals to r squared. Therefore, the center is 20 and 0. This becomes x minus 20. Then you square this plus y squared is equals to r squared. So, r squared, you don't know what is r, okay? But r is the distance from F to G. But let me substitute the point that passes through the circle, which is F, okay, at the point of contact with the tangent. So that is going to be 8 minus 20. Then you square this, and then a plus, what is the value there? It's going to be 6 squared is equals to r squared. Therefore, my r squared is going to be, I have to use calculator here. This gives me 180, right? So therefore, I have x squared, x minus 20, and then I square this plus y squared is equals to 180. And now I need to expand this, bringing 180 this side. This becomes x squared, x times 2. X times 20 times 2 is negative 40x. Then minus 20 squared is plus 400 plus y squared minus 180 is equals to 0. Therefore, this is x squared plus y squared minus 40x, and then 400 minus 180. 400 minus 180, guys, is plus 2 to 0. That is equal to 0, that equation, okay? That is equal to 0. So now, that is what they are looking for. It's x squared. So it means the coefficient of y there is 0. So you can leave your answer like that, or you can just, I see that they also want y. So you can say that that is x squared plus y squared minus 40x, and then a plus, they just bring that 0, y, okay, plus 2, but I don't think it's mathematically allowed. But let's just write it. But for argument's sake, this will really end here. Here I'm just trying to demonstrate your understanding of the question, how they are putting it, okay? They are saying that it should be in that form, but y is 0. Okay, the last question, 4.6. They say that the smaller circle must be translated by k units along the x-axis. Okay, so let's have that space. This is the smaller circle. Oh my goodness. So this is the smaller circle. This is the smaller circle, beautiful people. So that is the smaller circle. It must be translated by k units along the x-axis to touch the larger circle internally. So now if you translate it here, it's going to be touching the circle externally. And if it is externally, it means that the distance between their centers, which is the distance of the smaller of the smaller circle, and the distance, the distance between their centers, it must be the same as the sum of their radius. But now they're saying so that it can touch the larger circle internally. So internally, basically, we mean that the circle must be here. This is now called internally. So these circles are now touching each other internally. Okay, they say calculate the possible value of k. But now I want you guys to see something. We have moved the circle along the x-axis by how many units? By k units to the right of the circle. So what it means is this circle here, which is x squared plus y squared is equals to 20. Remember, this was the smaller circle. This guy is moving along the x-axis to touch the circle internally. So now we have affected the movement on the x-axis, which is it moved to the right. That means it's going to be x minus k here, and then you square this. Okay, plus y squared is equals to 20. The largest circle, remember, it has the equation of x minus 20, and then you square this plus y squared is equals to 180. This is the bigger circle. Now, they are basically testing you on the knowledge of internal circles. By that we mean, beautiful people, the distance between the two circles. Let's call the first circle A, and then the second circle B. The distance between AB, that should be the same as the radius of the largest circle, which is B, minus the smaller circle. The radius of the smaller circle, which is A. Therefore, the distance between these centers is going to be 20 minus k. Okay, this should be no. The coordinates of A. Let me put it down. This should be k and 0. This is the center. The other one is 20 and 0. No, I was right actually. So this is k minus 20, but it's the distance. Then you square this plus 0 squared. Think about it. And then now the radius of the big circle is the square root of 180. So if you square 180, that is 6 minus root 5 minus the radius of the smaller circle. You square 20, you get to the square root of 5. So therefore, you have the square root of k minus 20. Then you need to square this. And then this will give you guys 4, the square root of 5. Now you can see that the square root will undo the square inside there. It's a perfect square. It's going to be k minus 20 is equals to 4, the square root of 5. Therefore, the value of k here should be 4, the square root of 5 there, plus 20. Unfortunately, I don't have any other method to show you, but this should be the value that we are interested in. Thank you very much, guys.